Hi. Good morning, good morning, good morning, good morning. It's 5:20 in the morning. Oh my gosh, I went to bed like 9. No, maybe it was 10. But I've got like so much sleep. I got so much energy. I'm so ready to go. I haven't recorded in so long. This is like gonna be so much fun. Okay. So kids, we have now finished Unit 7. This is day 6 review. And that's what you're here for. So hopefully you've already done these problems. Hopefully you've already checked the answer key. The answer key is online, www.mrkraus.com. You all know the website. By the way, if you haven't hit the subscribe yet button and you're one of my students, oh man, are you in trouble. But anyway, what was I going to say? Oh, let's just get going. So, anytime you see this thing, first of all, I want you to get in the habit of, underlining, highlighting, whatever. Hundreds place. Round the answer to though. What the heck is that? That's embarrassing. So we're going to put this in our calculator. All we got to do is round it to the nearest hundreds place. But we got to remember how to put it in our calculator. So that's one of the reasons I want to start it with this. You're not able to put it in just by yourself. You have to use one of the buttons and features of the calculator, and it happens to be right here. Click on this, and there's lots of stuff in here, lots and lots of stuff in here, but we're going to use this one right here. See, degrees, minutes, seconds. Click on it and enter. I think I'm having problems with my calculator. Oh, there it is. My goodness, what's going on? So anyway, there's degrees. So I don't remember what it is now. It took me for so long. 32:20, 32 degrees, 20 minutes. And I think it was 35 seconds, wasn't it? 35 seconds, 35 seconds. Enter. Oh, I hate it when it's a fraction. Fractions. But we just hit Control Enter, and it turns it into a decimal. And you know it's going to be 32 point something. So 32 point, hundreds place is right to that 4. So 34 degrees. Done. Yay. All right, convert this to DMS. Round to the nearest minute. Round to the nearest minute. So, okay, we could do that. We're going to say, okay, 6318, 63.18, but not 63.18. Now, I know it's going to be 63 degrees, something minutes, something seconds. Now, I'm going to write it all down here. 63, that'll be more fancy. There's degrees, something minutes, and then the seconds I'm going to write all down. So we go into here in the catalog, right here in the catalog, and we're going to click on DMS. Now, if it happens to be all the way at the top up here, and you don't want to click the down arrow, down arrow, down arrow, down. You'll be here forever, right? You just hit the D button. D for, go to the D's, dummy. And then keep going until you see DMS. And you click enter. So it says, okay, take this in from degrees and degrees, minutes, seconds. Turn in degrees, minutes, seconds. Why am I doing that? Why is it exactly 48? I think actually that's probably right. That's okay. Okay, we're in good shape here. So what happens is you get 68 degrees, 63 degrees, 10 minutes, 48 seconds. Oh, I know why I picked this one. Okay, I picked this one because it's really close to 50. So you're like, oh, we're not going to round. It's going to be 68 degrees, 10 minutes. It's not 10 minutes. Remember, the cutoff is 30, like 30 seconds or 30 minutes. That's the cutoff. So since this is bigger than 30, this should be 11. And since we're rounding to the nearest minute, we don't even need seconds. So there's our answer, 63 degrees, 11 minutes. Remember, the key is 30. And guess what I'm going to test you on the test? I'm going to test that you actually check for that. Find the length of an arc. Oh, arc length. We're talking about arc length. As soon as I hear arc length, I'm going to write S equals theta r And you have to remember that S is the arc length. Theta is the angle in radians. And R is the radius. So as soon as I see this, I'm like, well, can't use that. That's not going to work. Let's convert it. 30. Got to multiply by pi over 180. You end up with 30 pi over 180. And if you put the 30 over 180 in your calculator, it would tell you pi over 6. It would tell you 1/6. So the angle that we have to use is pi over 6. So find the length of the arc subtended by a central angle of 30 degrees and a radius of 8 feet. So my arc length, I don't know. My angle is pi over 6 because I've already converted it. And my radius is 8. So I just come over here and I say, okay, S, which I don't know, is equal to pi over 6 times 8. Oh, and I need to round it to the thousands place. So I go to my calculator and I say, okay, control division, pi over 6 times 8. Enter. 4.1887 4.1887 902. And we want to round this one. That's the third one. So my answer for this is, I want to make sure I don't get in my head's way. Get all this stuff out of the way. My answer is 4.189. There's my answer. Next problem. The minute hand of a clock is 8 inches. So I know I have a clock. And I have a minute hand that's 8 inches long. All right, and I don't care where you draw it. There's my minute hand. It's 8 inches long. Now, what it says is exactly how far does the tip, there's the tip, go, move in 30 minutes. Well, 30 minutes, that means it's going to be down here, coming along, 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 coming along. And then the tip's going to end up over here. So my minute hand will end up over here, and my tip will end up right there. So really what it's traveled is half of a circle, which we know in degrees, that's 180 degrees. But we also know that if I can't use 180 degrees, because when I'm talking about arc length, I need to talk about radians. So I know that 180 degrees is pi. So I'm going to use my formula, S equals theta R. And I say, okay, exactly how far did the tip travel? Okay, the tip is, we're going to find out the arc of the tip. So we're finding S. So S equals theta times the length of my hand, which is 8. And did I say exactly? I said exactly. There's the answer. S equals, it's ugly. S equals 8 pi. Pi 8 doesn't make any sense. S equals 8 pi makes more sense. All right, let's convert these. So I'm got convert to radians. So we're going to multiply by pi over 180. So really what I have is 135 pi over 180. On this one I have 210 pi over 180. On this one I have 18 pi over 180. On this one I have 15 pi over 180. But we want to simplify those. We want to leave those like that because I really don't understand that. That doesn't make any sense. So I take my calculator, 135 over 180. 135 divided by 180. It tells me a nice little fraction, 3/4. So this one is really 3 pi over 4. Remember, you're going to grab your calculator for this. 210 over 180. Just don't put in the in the pi. 7 pi over 6. 18 over 180. Well, that's easy. That's just pi over 10, because 18 goes into 180 10 times. And then 15 over 180. So 15 divided by 180, 12 times. So we're going to go, this is pi over 12. All right, there we go. Answer, 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 answer. All right, to convert back, convert from radians to degrees, we're going to multiply by just the reciprocal of that. What we want to do is get rid of the pi. So if in order to get rid of the pi, I'm going to put the pi down here, because that's how you get rid of it. We're going to divide it out. But I got to multiply by the conversion, which is 180 over pi. When I multiply by conversions, I like to drink Burger's coffee, even though they don't pay me anything. But I still like to drink it. Ooh. Okay, so the pi's cancel. And this is what I'm left with. 7 over 4 times 180. So I'm going to do it this way. Control division. 7. Oops. Escape. Hitting all the wrong things. Control division. 7 over 4 times 180. 315. So this is 315 degrees. We just get rid of the pi's and we just multiply the stuff that's there. So 180 over pi. The pi's go, and you multiply 2/3 times 180, and that would tell you 120 degrees if you used your calculator. I'm trying to avoid using my calculator because it's too much work. Multiply here by 180 over pi. The pi's cancel, and I'm left with negative 450 degrees. You don't believe me? Negative 5 divided by 2, enter, times 100, not 1,000. Good. I knew I was wrong. Why am I wrong? Oh, I multiply by 100. I know I'm not wrong. Let's try this the right way, kids. Divide, control division. Negative 5 over 2 times 180. Oh, now I'm going to be right, 450 degrees, but negative 450 degrees. And don't forget that negative makes a huge difference. If you don't have the negative, guess what? You're wrong. And this would just be negative 270. But you're multiplying by 180 over 2, and you put in negative 3/2 times 180. Now, another way, just another fast way to do this, if you want to think about it this way, is doesn't pi really just equal 180? Sure does. So I can just do 7 times 180 over 4 and put that in my calculator. If I want to. Just substitute. All right, let's move on to the next number, 12. All right. 3, 4, 5, right triangle. That's one of those Pythagorean triples. Now, for those of you that didn't know that was a Pythagorean triple, you could always do 12 squared plus x squared equals 13 squared, and then just do 144 plus x squared equals 169. Subtract 144, and you get x squared equals 25, or x equals 5. Look how much work I saved just by knowing the 5, 12, 13 right triangle. All right. Before I continue, I think it's imperative that I absolutely label this OA and H. This is my angle, so this is H, this is opposite, and this is adjacent. So, sine of theta equals cosine of theta equals tangent of theta equals cosecant of theta equals secant of theta equals, and cotangent of theta equals. Some old hippie. Opposite over hypotenuse. 5 over 13. So this one's 13 over 5. Caught another hippie. Adjacent over hypotenuse. or 13 over 12. Tripping on alligators. 5 over 12 on alligators. O over A on alligators. Or 12 over 5. The last thing you're going to do, last thing, is signs. Positive or negative, positive or negative. Well, in this case, I didn't tell you anything about a quadrant. I didn't tell you anything about anything. I just gave you this triangle, so they're all going to be positive because I don't know anything else. All right, let's move on to 13. So the only thing I was given was that sine is 4/5. And my angle is a cute little angle. It's a cute little angle. A cute little angle. I'll never do that again, except on the next problem. I got to do it again. But then I'm never going to do it again, ever. So in a cute little angle, still we got to figure out which one of the bow tie we're going to draw. We're going to draw this one, or we're going to draw this one, or we're going to draw this one, or we're going to draw this one. But if it's an acute angle, that means I'm in the first quadrant. Because okay, let me get rid of all that. So I know that I'm in the first quadrant because it's an acute little angle. So the angle has to be less than 90 degrees. So that means in the first quadrant, which is nice because when I'm done, everything's positive. When everything's positive, which means it's good, I like to drink Brugger's coffee. Makes me happy. You know, I'm just doing this to get a little break here, kids, right? Oh, yeah. By the way, if you're wondering about my hair growth, don't. It's growing. Yes. And guess what? If all of my students get 100% on the Radians exam, I'm going to let it grow for a year. Do you have any idea how painful that will be? I'll have a little ponytail growing out the back. I'm actually going to braid it. If you want to torture your math teacher, then you all better pass this Radians exam, because that would be the absolute most torturous thing ever. Just saying. Okay. So sine is opposite over hypotenuse. Let me put opposite, hypotenuse, adjacent down here. So sine is opposite over hypotenuse. And this is a 3, 4, 5 right triangle, so I'm done with that. Sine of theta. Cosine of theta. Tangent of theta. Secant of theta, secant of theta, and cotangent of theta. By the way, kids, I will have another video. If you're watching this right now, I will have another video that will post. I'm not gonna put it on this one. I'm just not ready for it. Some other things, and I'll do that tomorrow, probably, maybe later today. Depends on how motivated I feel. I got to do some more videos tomorrow anyway. All right, so here we go. Sine it. Oh, we already know sines, 4/5. Well, that means this is 5/4. Cosine is adjacent over hypotenuse, so that's 3/5. Secant is the reciprocal of that, 5/3. Tangent is opposite over hypotenuse, 4/3. And this would be 3/4. Yay, done. Oh, look, we got another. Cute little angles are always in the first quadrant. And you got to draw it with the x-axis. This is my angle. Always has to be drawn with the x-axis. And I was told that tangent, wait, hold on a second. This is opposite. This is hypotenuse. This is adjacent. Tangent is opposite 1 over adjacent 4. Now, this isn't one of those nice triangles, I know, so I'm going to have to come down here and go, okay, 4 squared plus 1 squared equals hypotenuse squared, or x squared. This is 16 plus 1, that's 17, equals x squared, so x is equal to the square root of 17. And at this point, you say, fun. So much fun, because having the square root just means you're going to have to rationalize. So, again, we're in the first quadrant, so the good thing is I know that they're all going to be positive. Oh my gosh, I am such a sick singer. All right. cosecant theta, secant theta, and cotangent theta. That's probably behind my head, isn't it? I probably should have done that up here. Let me do that up here because that's probably behind my head. So I did 4 squared plus 1 squared equals x squared. 4 squared is 16 plus 1 squared is 17, so that's 17 equals x squared. So x equals the square root of 17. Sorry, big head. Get your big head out of the way. Cotangent theta is... All right, because I'm going to forget to go change that, so it's behind my big head. So we know tangent is 1/4, so therefore, oh, don't need this. Cotangent is just the reciprocal of 1/4, which is just 4. But the rest aren't quite as easy. So let me actually get rid of these because we've got some work to do here. So sine is opposite over adjacent, opposite over hypotenuse, which is 1 over the square root of 17, which you have to rationalize by multiplying by the square root of 17 over the square root of 17, and you get the square root of 17 over 17. So that's that answer. Cosecant is just the reciprocal. We're going to take the reciprocal of that because it makes it easier, which would be the square root of 17 over 1, but I don't need to put over 1. So this one would be adjacent, which would be 4 over the square root of 17. Well, then that means this got to be square root of 17 over 4. But I do have to rationalize this. Multiply by the square root of 17 over the square root of 17. And I get 4 square roots of 17 over 17. Sometimes I wish I wrote as nicely as many of my female students, or also some of my male students that have very neat penmanship. You know who I'm talking about, you neat penmanship guys. I wish I could write like you. All right. The most important thing about this is exact value. Exact value to you means put your doggone calculator away, you lazy bum. That's what it means. That's what all it means. So let's take a look at this. Here's what I got. I've got the tangent of pi over 4 minus the sine of pi over 6. Well, the first thing I got to do is convert these things. So I know this is really 180 over 4. So now I know this is the tangent of 45 degrees minus the sine of 30 degrees. Well, luckily for me, I actually could have used my calculator, but I am going to expect to see work. This is really 1 minus 1/2, which is really just 1/2. I'll have more examples on my other video on how to do some more problems like this, so don't fret. I will have some more examples. This one's a little bit trickier. So it's 3 times the square root of 2 over 2, because this is the square root of 2 over 2. We just said this was 30 degrees, right? Minus 4 times, and the tangent of 30 is the square root of 3 over 3. So what I have here is 3 square roots of 2 over 2 minus 4 square roots of 3 over 3. That's not pretty. And I wrote it really huge, so now I'm going to have to try to write smaller. Oh, that's not going to be smaller. That'll be smaller. So my common denominator would be 6. So in order to make things both 6s, I had to multiply by 3 here, right? So my numerator I'm going to multiply by 3, so I get 9 square roots of 2 over 6 minus, I have to multiply this one by 2, so I can multiply this one by 2, minus 8 square roots of 3 over 6. Well, those can now be combined, sort of. The denominator is 6, but because these two don't have the same radical, you can't combine them. So it's really just 9 square roots of 2 minus 8 square roots of 3. Ooh, that was painful. Let's go over here. Okay, so this is really, we said 60 degrees, and this is really 90 degrees. So really what I have here is the cosine of 60 degrees plus the sine of 90 degrees. Well, the cosine of 60 is 1/2. The sine of 90 is 1, so this is just really 1.5 or 3/2. You decide. Let's just see. This is 60 degrees again. So this is 4 times cosine of 60 is 1/2. We already did that. Plus 3 times the tangent of 60 is the square root of 3. So this just becomes 2 plus 3 square roots of 3. No fractions. That's it, brothers and sisters. Brothers and sisters, mothers and fathers, I'm a silly singer, but I really I missed my calling. Oh, now I gotta So it says, use your calculator to approximate secant of 10 degrees rounded to the hundredths place. Wow, that's really difficult. So we go to our calculator, secant of 10 degrees. So control, nope, not control, secant. Oh, now we got all this crap here. Secant 10 equals 1 point, I'm going to write it all out, 1.0154266, 54266, 1189. 1189. Took me a second. So now I want to round it to the hundredths place. That's right here. So that I want to see. Let's see. I'm going to need to round that. So it's 1.02. Done. Find the value of the 6 trigonometric functions if 3, -4 is a point on the terminal side. So again, what I have here is I've got this point 3, -4. 3, -4, right here. It's on the terminal side of my angle. My angle would be here. It's on the terminal side. There's my angle. But we're not going to use that. We're going to use this triangle right here. Remember, we have to use one of the bow ties. Right? And we're in the 4th quadrant, so we're going to use this triangle right here. So I'll do that off to the side. And I went over 3, and I went down 4, and 3, 4, and the hypotenuse would have to be 5. So I don't need any of this. So now what I want to do is find the 6 trig functions. So sine of theta equals cosine of theta equals tangent of theta equals. So secant of theta equals the secant of theta equals the cotangent, and a brain fart there for a second, of theta equals. Sine is opposite over hypotenuse. That's 4 over 5. Oh yeah. Opposite, adjacent, hypotenuse. Cosine is adjacent over hypotenuse, 3/5. Tangent is opposite over adjacent, 4/3. And these are just the reciprocals. 5 over 4, 5 over 3, 3 over 4. All right, we're moving on. Oh, I was just kidding. You guys thought you got me on some bonus points. I was just kidding. Kids, what's the last thing you're going to check for? The S-I-G-N signs. Is it positive or is it negative? All students take calculus. So, in this quadrant, cosine is positive. These are going to be positive. That means this is negative, this is negative, this is negative, and this is negative. Yay! Okay. Moving on. Name the quadrant that theta lies if theta... so cosine of theta is. This does not mean greater than 0. It means positive. Cosine is positive. So all students take calculus. So I want to know where cosine's positive. Well, I know cosine's positive here. And since I got a C here, cosine is also positive there. Tangent is negative. Well, I know tangent's positive here, and I know tangent's positive here, so tangent must be negative here and here. So there's the big winner. Quadrant 4. Quadrant 4 is the big winner. Yay! Find the reference angle. Now, I ask you to find this reference angle in both radians and degrees. Now, don't forget, when we're dealing with reference angles, we want to get an angle that's close to 360 or 0 or close to 180. Now, 360 the same as 2 pi. 180 is the same as pi. So I want to get as close to 2 pi or 180 or 360 as I can. Well, this is almost pi. This is 4/5 of pi. That's just 1/5 away from being 5 pi over 5, which would be pi. So I'm pi over 5 away. So the reference angle in radians would be that. Not really going to test that too much, but just thought you smart kids would want to know. And since I only have smart kids, I thought you would want to know. So, but first thing we probably ought to do is convert this to radians. So take 180 over pi. We get rid of the pi's. Say, see ya, wouldn't want to be ya, goodbye. And I take my calculator and I multiply negative 4/5 times 180, and it will pop out negative 144. Now, I don't care if it's negative or positive. I know that, well, it is negative. It's close to 180 over here. Negative 144. It's close to 180. So all you got to do is figure out how far away 180 and 144 are from each other. I care about positive or negative. Okay? I don't care. Just figure out how far away they are from each other. And they are 36 degrees. And that's the answer. All right. So the most important part of this problem is the words on the unit circle. Because this point, even though it doesn't look like 1, is on the unit circle. Now, I think I should have to prove that to you, so I'm going to. What is negative 3/5 squared plus 4/5 squared equal to? Well, this is 9/25 plus 16/25. And that equals 25/25, which is 1. That is why it is on the unit circle. This is, in fact, a point on some unit circle somewhere. So, if it's a point on the unit circle, then the x value simply represents the cosine, and the y value simply represents the sine. So those two are easy. Sine of theta is equal to negative 3/5. Brain fart. Let me put these down here because I didn't write it. This is cosine, and this is sine. But sine of theta is equal to 4/5, and cosine of theta is equal to negative 3/5. Now, the only thing left for you to do is figure out what in the world tangent is. So that's actually the hard part. So here's how you find tangent. Well, first of all, you got to decide what quadrant you're in. What quadrant are we in when x is negative and y is positive? That would mean we are in quadrant 2. Here's my angle. Now, cosine is 3/5. Tangent is 4/5. So we're in this quadrant, 3/5, 4/5. So what is tangent? Well, tangent, theta, is opposite over adjacent, 4/3. The last thing you have to remember to do is check your signs. All students take calculus. All students take tangent's positive down here. So tangent must be negative calculus. All right, so these four very simple looking questions are not that simple. You have quite a bit of work to do. So sine of theta equals cosine of theta equals tangent of theta equals cosecant of theta equals, what was I doing? Oh man, secant of theta equals. I just had some coffee too, and all of a sudden I had a brain fart. Cotangent of theta equals. Now, the only information that this stuff gives you is where the triangle is. That's going to tell you where to put your triangle. It has to be one of your bow ties. It has to be the first quadrant, the fourth quadrant, the third quadrant, or the third quadrant. It has to be one of these. So let's think. All students take calculus. Tangent is, now I don't care about 12/5. I care about that it's positive. Tangent's positive here and here. So I know it's not this triangle, and I know it's not this triangle. Sine is negative. Sine is negative. Well, sine is negative down here and down here. So it looks like quadrant 3 is the winner. So that information just told us that we're going to draw our triangle in the third quadrant. Okay, so now we can get to work. Let's go. Tangent, wait, there's my angle, is opposite over adjacent, and this is the hypotenuse. So tangent is opposite, which is 12, over adjacent, which is 5. And this is a 5, 12, 13 triangle. Of course, if you needed to do the Pythagorean theorem, you could. So let's see. Oh, by the way, I know this is 12 over 5, so I know this is 5 over 12. That's nice. Sine is opposite over hypotenuse. That's 12 over 13, so this is 13 over 12. And cosine is adjacent over hypotenuse. That's 5 over 13, and this is 13 over 5. And the last thing you're going to check for is the sine. All students take. Only tangent's positive down here. That means these are positive, which of course we already know because they gave them to us positive. So that means these have to be negative. Please, 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 make the last thing you do is check your signs. All right. Let's figure out what quadrant our triangle is in. Is it going to be the first quadrant? Is it going to be the second quadrant? Is it going to be the third quadrant? Or is it going to be the fourth quadrant? Which of the bow ties are we got? Oh, Kraus, you're mean. This is the same as cosine, sort of. So cosine is negative. All students take calculus. Cosine's positive here, and cosine's positive here. So cosine must be negative here and negative down here. Tangent is negative. Well, tangent's positive here and positive here. Tangent's negative here and negative here. So that's the big winner. So I don't need the rest of them. I need a triangle in quadrant 2. So, in my triangle in quadrant 2. There's my angle. So let me go over here. Sine of theta equals cosine of theta equals tangent of theta equals, I just like saying theta equals cosecant of theta equals secant of theta. Anybody else sick of that? Equals all right, let's see. What did we already know? We already know that secant is negative 5 over 4. So that means this has to be negative 4 over 5. We just flip it. Well, if cosine is, this is opposite, this is hypotenuse, this is adjacent. Cosine is adjacent over hypotenuse, 4 over 5, and that makes this 3. So those are my sides. Sine is opposite over hypotenuse, 3 over 5. Cosecant is the flip of that, 5 over 3. Tangent is opposite over adjacent, 3/4. This would be 4/3. The last thing you're going to do, kids, is check your signs. All students, signs are going to be the only thing that are positive. That means everything else is negative. These are already negative. I got to make these negative. Done. Problem's over with. Check your signs last. Please, please, please. Oh, I was so nice to you on this one. I just told you the quadrant. Bam! Quadrant 3. Of course, that's not going to help. Let's do it over here. Again, it's got to be one of the bow ties. Don't mess with the y-axis. We only deal with the x-axis. If you mess with the y-axis, you will be asking, why did I fail trig, Mr. Krause? And I'll be like, you messed with the y-axis. That's why. Opposite, hypotenuse, adjacent. Let's see. Sine of theta. Cosine of theta. Tangent of theta. Cosecant of theta. Secant of theta. Cotangent of theta. All right, what do we got here? Now, the only thing I know, the only thing I was given is cosine is negative 3 over 5. Well, that means this has to be negative 5 over 3. But I also know cosine is adjacent over hypotenuse, so 3 over 5. And again, remember I don't put the signs in because I take care of the signs by all students take calculus. 3, 4, this has to be 4. So sine is 4/5. That means this is 5/4. Cosine is adjacent, opposite over adjacent, 4 over 3. And this is 3/4. Now I'm going to take care of my signs. All students take calculus. All students take calculus. Tangent, or this, is the only thing that's going to be positive. That means this has to be negative and this has to be negative. Yay, one more. Oh my God, these are taken. Oh, Mr. Krause, you being mean. What's this crap? Radians. So sine of theta equals cosine of theta equals tangent of theta equals All right. What? What? All right. So let me get rid of my old work. Did you see it, buddy? Why can I not get rid of that? There it is. I think I'm pushing a button. Okay. So how do I do this? How do I go about doing this? Don't freak out. I'm telling you that my angle theta is between 180 degrees. And if you convert this, or you already know it, this is 270 degrees. So my angle is between 180 and 270. Let's see. 180 is here. And 270 is here. So what quadrant am I in? I'm in the third quadrant. So I'm going to draw my triangle in the third quadrant. So, and then all I was given was that cosecant, is negative 4. Well, that's really negative 4 over 1. So when I flip that, I get negative 1 over 4. And I know that's opposite over hypotenuse. So opposite, adjacent, and hypotenuse. So let me get these in black. 1 opposite over 4. So now I got to figure out what this missing side is. So 1 squared plus x squared equals 4 squared. Remember, the hypotenuse always has to go on the right side. So this is 1 plus x squared equals 16, x squared equals 15, or x equals the square root of 15. So now I know this is the square root of 15. So cosine is adjacent over hypotenuse, square root of 15 over 4. That means this is 4 over the square root of 15, which is now going to get ugly because I got to multiply by square root of 15 over the square root of 15, and I get 4 square roots of 15 over 15. And tangent is opposite over adjacent, so this is 1 over the square root of 15, and if you rationalize this, you end up with square root of 15 over the 15. And this is just the reciprocal of this, which is just the square root of 15 over 1, which is just the square root of 15. All right, here we go. So all I'm telling you, the most important thing I'm telling you is that this point xy is on the unit circle. And if it's on the unit circle, then you have to remember that x is cosine and y is sine. So I'm telling you theta is 120 degrees. Now you had to convert that, multiply by, take 2/3 pi. Where am I? How did I get there? Take 2 pi over 3 and multiply by 180 over pi, but it converts to 120. I will never ask you about 120, but this is 120 degrees. I don't care that that's 120 degrees. What I want is this angle, which is 60. That's the reference angle. So what is the cosine of 60 degrees? 1/2. What is the sine of 60 degrees? Radical 3 over 2. Okay, so x, which is equal to the cosine, is 1/2. And sine, y, which is equal to the sine, is the square root of 3 over 2. But you're going to remember that the last thing you have to check is signs. S-I-G-N. All students take calculus. Sine is positive in this quadrant. Therefore, cosine, or x, is negative. And it kind of makes sense. Aren't x's negative on this side? All right, so 7 pi over 6. So theta really equals 210 degrees. And that kind of makes sense. But I don't care about that. I care about this. So if this is 210, I only want this piece. That's 30. So my reference angle is really 30 degrees. So x, which is equal to the cosine of 30 degrees, is equal to radical 3 over 2. And y, which is equal to the sine of 30 degrees, is equal to 1/2. Now remember, it's really not 30 degrees. We're really using 210 degrees, but I needed to use the reference angle to get those numbers. So, let's see, all students take. Tangent's positive down here. That means sine and cosine are both negative. Done. Let's convert pi over 3. That's just 60 degrees. Oh, that's in the first quadrant. Well, good thing is I know everything's positive in the first quadrant. And so the cosine of 60 degrees, which is x, is 1/2. And the sine of 60 degrees is the square root of 3 over 2. And since we're in the first quadrant, everything's positive. There's my answers. And finally this one, 4 pi over 3. If I convert that, I end up with, let's see, 120, 60, 240 degrees. So I end up with theta equals 240 degrees, which of course puts me in the fourth quadrant. But I don't care about that. I care about this 60 degree reference angle. So cosine of 60 degrees is 1/2. And the sine of 60 degrees is the square root of 3 over 2. But I'm in the third quadrant, and I know in the third quadrant sine is negative and so is cosine. All right, kids, we're moving on. We're on 29. We're getting close. Okay, these aren't bad questions, but they are kind of tricky. So, here's my angle. Opposite, hypotenuse, and adjacent. Which sides are in play? A and H. That's cosine. So cosine of 30 degrees is equal to A over H, 18 over x. Now, because I asked for the exact value, that means touch your calculator, get a 0. Okay? You don't need your calculator. You don't need it. So, but I got to remember. Now, again, kids, if you don't remember what the cosine of 30 degrees is, you're like, okay, is that a half or is it square root of 3 over 2? You just you could do in your calculator. What is going on? Cosine of, that's weird, 30 is, oh, that's not a half. So that's got to be the square root of 3 divided by 2. Oh, yeah. Okay, so that's the square. So square root of 3 divided by 2 is equal to 18 over x. This is how you do it exact. Cross multiply. And I get 36 is equal to x times radical 3. Well, I still got to get x by itself, so I got to divide by radical 3, divide by radical 3. You can't leave it like this. You have to rationalize it. So we're going to multiply by radical 3 over radical 3. So I end up getting x equals 36 radical 3 over 3. But 3 goes into 36, so x is equal to 12 radical 3. No worries, kids. We got a few of these to do, and I know that was kind of tricky, so let's keep going. All right. This is your angle. That's your angle. Opposite, hypotenuse, adjacent. Again, I use cosine because I'm using adjacent and hypotenuse, so cosine of 45 degrees. In this case, it wouldn't matter because sine of 45 and cosine of 45 are the same, is equal to adjacent 12 over hypotenuse x. Well, I know that the cosine of 45 is the square root of 2 over 2. So that's equal to 12 over x. I just know that. So now I'm going to cross multiply, and I get x times radical 2 equals 24. I'm going to divide by radical 2. And I just have to rationalize this. So I'm going to multiply by radical 2 over radical 2. And I end up getting x equals 24 radical 2 over 2, which is really equal to 12 radical 2. There's your answer, kids. All right, 2 more of these. So here's my angle. This is opposite, this is adjacent, and this is hypotenuse. Doesn't matter about the hypotenuse, so I need O and A. O and A just screams tangent. So tangent of 60 degrees is equal to opposite, which is 15, over adjacent, which is x. Now, let's say you don't remember what the tangent of 60 degrees is. So you come over here and you say, okay, tangent 60. Why is this calculator not working properly? Tangent of 60. Okay, is that the square root of 3? Oh yeah, square root of 3. So this is the square root of 3 over 1 equals 15 over x. We'll either cross multiply or multiply both sides by x. So I get x times the square root of 3 equals 15. All right, now I got to divide by the square root of 3. Divide by the square root of 3. And that's what x equals, but I got to rationalize it. So multiply by radical 3 over radical 3. So I get x equals 15 radical 3 over 3 when I do that math. Or x equals 5 radical 3. One more. All right. Using this angle, this is opposite, this is adjacent, and this is hypotenuse. So again, we're using A and H, cosine. So cosine of 45 degrees is equal to adjacent x over hypotenuse 20. Oh, this one's going to be a little bit easier. Well, this is really the square root of 2 over 2 is equal to x over 20. We'll cross multiply. So 2x 20 is equal to 20 times radical 2 divided by 2 divided by 2. And I get x equals 10 radical 2. Well, that was easy. When problems are easy, I finish my coffee. Not done yet. All right, so the trick with word problems is trying to make sense of them. The other thing you should remember is the only thing we've worked on is right triangles. So you know you're going to have some kind of right triangle. All right, let's see if we can make sense of this. A hot air balloon. Well, if I had a hot air balloon, that would probably be up in here. So the balloon's going to be up here. Is tethered to the ground by a 250-foot cable. Oh, ground. Ground's got to be down here, right? And makes an angle of, so the wire. So this has to be the height. That means this has to be the wire or the cable. The cable. So we have a 250-foot cable, and it makes an angle of 52 degrees 20 minutes with the ground. You have to include the minutes. So while I'm here, I might as well opposite. Ooh, I should have called this altitude. Opposite, hypotenuse, and adjacent. The question is, what is the altitude? So we're going to call this x. So we need opposite, and the only thing we have is hypotenuse. So that's sine. So the sine of 52 degrees 20 minutes is equal to opposite x over hypotenuse 250. Well, I just cross multiply on these. So I get x equals 250 times the sine of 52 degrees 20 minutes. I don't know that one. So I got to come over here. So 250 times the sine. Now some of you on Monday are going to, or Tuesday are going to ask me, Monday for sets 1 and 3, or 2 and 3, and then Tuesday for set 4, just in case you forgot, are going to say, oh, I put in 52, but it's not exactly 52, and then you're going to put in 52.2. Oh, no. You can't put them in like that. You got to come in here, and you got to use this thing right here to get those degrees, minutes, seconds. Ka-chang, ka-chang. 52, 20. Enter. 197. So x equals 197.894792. 894792. Rounded to the nearest foot. 198. Rounded to the nearest foot. Moving on. A helicopter with a ground search beam directed towards a point on the ground observes that the angle of depression of that point from the helicopter is 30. What the? I don't think this is written very well. So let me draw my helicopter because I am an unbelievable drawer. Oh, you know that's awesome. You know that's awesome. You know that's awesome. Right triangle. You know you have to have a right triangle. All right. So there's a point on the ground. So this is the ground. If the, let's see, angle of depression, so we talked about this on Friday, angles of depression, if let's say the helicopter is looking straight out like this. So the helicopter is looking in this direction. Angles of depression come down. So this is 32 degrees, 10 minutes. And this is my point. And it tells me, somehow we know my laser beam, or my beam of light, is 840 meters long. And the question says, find the altitude of the helicopter. I want to find this. Well, unfortunately, the only angle I'm giving is this one. So maybe instead of using that green triangle, maybe what we'll use is this triangle, because they're pretty much the same thing. So if this is my altitude of my helicopter, so is this. So I think I have everything I need here. Let me give a different color. This is opposite. This is hypotenuse. This would be adjacent. I'm using O and H. That's sine. So sine of 32 degrees 10 minutes is equal to x over 840. Hey, this is an easy one. Cross multiply. I get x is equal to 840 times the sine of 32 degrees 10 minutes. Look, kids, if all else fails and you don't understand the diagram, just start taking right triangles and start finding sides and angles. You're probably going to get something right. So here we go, 840. I mean, you got to try to make sense of it, but, you know, if all else fails. So I need 32 degrees, 10 minutes. It means I have to go into this button right here. Don't forget that. And type in 32 degrees, 10 minutes. And I get 447.20246. So x equals 447.20246. 46818. 46818. Let's see. I come back up. What's the altitude to the nearest meter? So x equals 447. All right, chillin'. This one gave me a drawing, so I don't really need to do anything. What do I want to do? No. How high above the ground to the nearest tenth is the top of the ramp? Well, here's the top of the ramp. So really what I want to do is find out how tall this wall is. So that would be opposite. This would be hypotenuse. So we're using sine. This one's not bad. Sine of 32 degrees is equal to opposite, which is x, over hypotenuse, which is 30. So x equals 30 times sine 32 degrees. So x equals 30 times, I know what's going on with this. Oops, it doesn't like when I touch the screen. Sine of 32. So 15.897, 15.897, 5779, 5779, close enough. To the nearest tenth. So x equals 15.9. Ka-chang! So from a point on level ground, 25 feet, probably not seeing what I'm doing here because I'll try to remember to move my head on this one. 25 feet from the ground. Let me move it up at least a little bit. Maybe it's away from my head then. Base of the tower, elevation, 78 degrees. Find the height of the tower. So we really want to just find x. So that's opposite and adjacent, because this is the hypotenuse. So that's tangent. So we need to use tangent of 78 degrees is equal to opposite x over adjacent 25. Again, I gave you a simple one. X equals 25 times, and we're going to cross multiply. Tangent 78 degrees. So x equals 25 tangent 78 degrees. 117,615, 117,615, 752. Should be probably enough. We got to round to the nearest tenth of a foot. So x is equal to, that's this, 117.6. There it is, chillin'. A communications company is building a 30-foot antenna. That's this. The diagram below shows a 50-foot wire. We want to know what the angle to the nearest degree, to measure the angle the wire makes with the ground. Well, there's the wire and there's the ground. So I'm looking for this. Now, as soon as you see nearest degree, inverse trig, you know you're not going to be doing regular trig. You're going to be using the inverse functions. Because, let's see, this is opposite and this is hypotenuse. So sine of x is equal to opposite, which is 30, over hypotenuse, which is 50. Now, if I need to find an angle, then I need to get rid of this sine. I need to take the inverse of both sides. And I want to see this works. X equals the inverse sine of 30 over 50. Remember, in order to get rid of that sine, you can't divide by it. You got to take inverse. Don't get in that cross-multiplying monkey routine, okay? Inverse trig. So we're going to go sine inverse of 30 divided by 50. And you get 36.869. X equals 36.869. 897. 897. And we want to round to the nearest degree. So we're going to see if we're going to round this. And this is an 8, so the answer is 37 degrees. Ka-ching! In right triangle ABC. So I'm going to right triangle ABC. I'm going to actually read the problem. AB equals 20, AC equals 12, BC equals 16. Ooh, wait, this is important. The measure of angle C is 90 degrees, so this has to be C. It didn't say anything about the other two, so they can just be A and B, but if you did not put C in the right place, you will not be able to get this right. AB is 20, AC is 12, and BC is 16. It says find the measure of angle A. Well, you have your choice. You can use opposite, adjacent, or this is hypotenuse. I'm just going to use, I guess I'll just use opposite and hypotenuse. Who cares? Sine. It's the first one on the in the calculator. So sine of angle A is equal to 16 over 20. Again, it wouldn't matter if I did cosine of A is equal to 12 over 20. Or tangent of A is equal to 16 over 12. They will all give you the same answers, and I'm going to prove that in just a second. So, in order to solve these, we got to do inverse trig of each one. Inverse, so in this case, I'm just going to do one of these. A is equal to sine negative 1 of 16 over 20. Well, this is equal to A equals cosine negative 1 of not 12 over, this is 12 over 20. 12 over 20. Or A here is equal to the inverse tangent of 16 over 12. They all should come out to be the same. So, inverse sine of 16 over 20. Oops. Forgot something. 16 divided by 20. Inverse cosine of 12 divided by 20. And inverse tangent of 16 divided by 12. It wouldn't matter which one I picked. They're all 53 point, so 53.130, 53.130, 102. Let's see, what do we have? What do we have? What do we want around to? The nearest degree? 53 degrees, kids, 53 degrees, 53 degrees. There it is, round to the nearest. Okay, moving on. 36. The last one, 37, by the way, is hard, so make sure you pay attention to 37. A 28-foot ladder. I don't know what that means. We got a building. We got a 28-foot ladder. There's my ladder going up to the building. All right, so it's a 28-foot ladder. The bottom of the ladder, that's down here, is 6 feet from the base of the house. Yes, I know it doesn't look like 6 feet. Find to the nearest degree the angle formed by the ladder and the ground. Well, here's the ladder and here's the ground. Okay, so now I'm going to grab O, A, and H. O, A, and H. And that we're using A and H, so we have to use cosine. So cosine of, I don't know what you would call this, x. Cosine of x is equal to A, which is 6, over H, which is 28. Got to bring the cosine over because we got to use inverse. Cosine is equal to, or x equals cosine negative 1 of 6 over 28. I want to see you write that. So trig down 1 over 1 of 6 divided by 28. And I get 77.62. X equals 77.62. 637. 488. Round to the nearest degree. X equals, let's see, I got a C. This is a 6, so it's going to round it up to a 78. All right, 37. I should have done these in class. All right, so these are kind of tricky, so pay attention. Pay attention. We need to figure out where if I was to just do this, theta is equal to, bring the cosecant over, I get cosecant negative 1 of 5.396. I get theta equals 5.396. 5.396 equals 10.6799. 10.6799. 33157. 3315. Okay, good enough. And if I rounded that to the nearest 10 minutes, I go, oh, okay, let's DMS it. And I said it's 10 degrees, 40 minutes, 47 seconds, blah, blah, blah. But that's not right. Because you have a very, very important piece, and that says that your angle has to be between 90 and 180. What? Wait a second. So, wait a second. Let's think about this. Here's 90 degrees. Here's 180 degrees. My angle has to be between 90 and 180, and I came up with 10? Something's not right here. What's not right? Well, the problem is this, and this is why we talk about reference angles all the time. This is my reference angle. This is my reference angle. This is my 10.67 blah, blah, blah angle here. But I'm in the second quadrant, so I have to be less than 180. Oh, how much less? This much less. So if I'm in the second quadrant, I want to say, okay, take 180 and subtract off. I'm not retyping that. This. That's your angle. And then we DMS that thing. And we get, I'm going to write it all out, 169 degrees, 19 minutes, 12.240, 12.240, 635. Now I want to say, okay, I want to round this to the nearest 10 minutes. So that means it should be 10 minutes, or 20 minutes, or 30 minutes, or 40 minutes. So let's see. This is where my minutes are. So I got to say, am I going to round that to 10 or 20? So, of course, it's 20. So my answer is 169 degrees, 20 minutes. All right. So before I even go on, I'm going to figure out where am I? 180. So let's go. 180 degrees. That's right here. And 270 degrees. That's right here. So I know I'm in this quadrant. So whatever reference angle I come up with, I'm in the third quadrant. So I'm going to say, okay, theta is equal to inverse cotangent, because remember, we're going to slide this over, inverse cotangent of 1.3575. So I go, okay, theta is equal to inverse cotangent of 1.3575. 1.3575. So I'm going to get an angle of 36 degrees. Now 36 degrees is in the first quadrant. I don't want that. I want to be in the third quadrant. So that means that I've got to go at least 180 degrees and then 36 more. So I'm going to add, in this case, I'm going to add 180 degrees. And I'd say, okay, 216. Okay, that puts me in the third quadrant. My eyes are killing me. And then I just have to DMS this thing. So now I'm going to DMS it. So menu DMS. 216, I'm going to write it all out. So 216 degrees, 22 minutes. Don't be lazy and not write this out and not get any partial credit at all. 37.748, 989. Okay, so now I want to round it to the nearest minute. So let me highlight what the nearest minute is. The nearest minute is this thing. So, no, it's not. That's seconds. Ooh. This is the nearest minute. This is minutes, right? So I have to decide 37. Am I going to round this up or down? Remember, 30 is the cutoff. So this thing is going to round the 2 up. So my final answer is theta equals 216 degrees, 23 minutes. And again, if you don't have this calculator, it might be a nice time to go get one. You're going to need one, something for college anyway. All right. Did I miss one of these? I thought I missed one of these. I thought there were 4 of these. I think there are 4 of them. Oh, maybe not. Weird. All right, I thought there were 4. So this one's 270 to 360. Here's 270. Here's 360. So clearly I'm in the 4th quadrant now. So now I'm going to be, when I'm done, I'm going to be in the 4th quadrant. All right. So theta is equal to secant -1 of 2.6943. All right. Oops. So, ding, 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 ding. Secant of 2.69, 2.69, I think it was 43, right? 43, enter. 68 degrees, but remember 68 degrees is up here. This is 68 degrees, so I want this to be 68. So if I come all the way to here, it's 360 degrees. If I add 68, I'm like back into the first quadrant. I don't want to do that. What I want to do is I want to come back 68 degrees. So I'm going to subtract 68 degrees. So I'm going to take 360 and I'm going to subtract, I'm not typing this thing. And that will tell me, oh, 291. Isn't 291 in between 270 and 360? And that's what I want to be. So theta equals, now I'm going to DMS this, and I'm going to write down exactly what I see. 291, 47, 12.4, oh, 479, shoot. 479, 99137, 99137. Okay. So now to the nearest second. That means I'm going to be rounding this thing. So this is a 4. I'm not rounding it. It's just staying 12. So my answer is theta equals 291 degrees, 47 minutes, 12 seconds. All right, kids, that is the end of the video. That is the end of the review. Tomorrow, at some point, I will post another video that really should help you for the final exam. So sometime tomorrow I'll get that posted, but it really should help you on the final exam. So check back tomorrow. Hopefully you did pretty good on this, but if you want some more review, it's all up to you. How much do you want to work for your grade? Do you want to work for it, or do you want to be lazy? I don't care. Hit like, hit subscribe. Peace out, kids. Good luck. Work hard. World does not need any more losers. We got enough. We need more winners. Goodbye.